So, students, those who have just joined, so what we are doing, we started with the center of mass of the point masses, and this is how we have written, and then with the continuous mass, so we divided the extended body into small masses, and then we wrote this formula. But as which coordinate I am going to take for like m1, so there are so many coordinates, so many points. So to need this center of mass to be accurate, I need to divide this delta m. I want it to be smaller and smaller. So if I want this mass to be smaller and smaller, so definitely the number of masses will be increased. So number of masses reaches to infinity, the number will become larger and larger, and this their masses will become smaller and smaller. So these are the changes that will be there in this formula. So what are the changes? So sigma will be changed to integral sign. So this is integral sign. Okay. This is integral sign, long S. So it also means sum. Okay. It also means sum of those the infinite changes. So here dm is changes. So sum of all the masses. It also means sum. So delta is changes to d. So d also means small change. Okay, infinitesimally small change. And this I will be removed because the number has become infinite. So any arbitrary you are taking. So here also I'm taking any arbitrary element as a dm here. So and then whenever we this change dm, this infinitesimally small mass or anything infinitesimal, we write it at the end in the integral. Okay. So and we discussed this case yesterday of the rod. So this mass element of the rod I am taking dm, and its length is dx. So and this case the rod has uniform density. Okay, uniform mass density further if you want to say. So what is the formula for linear mass density? So linear mass density is equal to mass upon length here, not area, because I am considering only the length. And so rod, wire, we consider the length only. And what is the symbol for linear mass density? It's lambda. Lambda is equals to mass capital M and length capital L. So this is the length of this rod, and the mass of this rod is M. Okay. Now this is uniform density. So lambda will be same everywhere. So I can further write it as lambda is equals to dm dx. So what will be the density of this mass? So this is dm upon, so mass is replaced with dm and length is replaced with dx. So it's as simple as that, students. Okay. Now you have to put the value of so x center of mass we want to calculate, we want to find. So this x is equals to dm. So what is the value of dm? You will get it from here. So dm is equals to lambda upon lambda into dx. And what is lambda equals to? So put the value of lambda. So lambda is equals to m upon L. So it means dm is equals to lambda into m upon L. So you need not to do anything. Simply put this value over here. So x into what is dm equals to? Sorry, students, why you people are not interrupting me? Why people? What is the value of lambda? I am writing. What is the value of lambda? Lambda is m by L. You will be writing the value of lambda m by L into dx. So dm is equal to lambda dx. You people are, I think, writing. Okay. So participate along with me. I am just now this formula x equals to x into, put the value of dm, Are you people able to listen to me? Yes or
Yes,
no?
sir.
Yes, sir.
Yes, sir.
Yes,
So
sir.
why don't you people participate then? Divided by dm. So now this will equals to, so all the constant will always come outside the integral. And next thing is that this change dx is from where to where. Tell me this change. This change will always be, this is the change. We are changing the length. So how you are changing the length? Tell me the lower limit from where you are starting. You are starting from 0
0 to
and you
x.
are reaching up to L. So we are starting from 0. This change, we are adding all the length, right? From where we are going to start this dx, all the dx we are adding, okay? All the dx. So from where you are going to add the dx? We are going to add the dx, all the dx starting from 0 up to L. Is this clear, students?
Yes, sir.
Okay. Even you want to write the unit of this dm, so it is also, you need not to write it, otherwise you can write it from 0 to m. All the masses we are going to add it. So next step is, when you are taking integration, the constant will come out. So what are the constant? Mass of the rod is constant, length of the rod is constant, right? So m and L will come outside. So what you are left with? 0 to L and x dx. You can clearly see that x is, so here your x was this, so x will change depending on the location of dx. So x is variable, right? Yes. If the dx is over here, will the x be same? New x will be this, right? So this is variables. So variables will be inside, and now this is what is sum of all the masses, sum of all this infinitely small masses will get the mass of the rod. Okay, this m upon L into, this is m upon 1, so dividing it, so it will be 1 upon m. Okay, and then now let us do the integration. So integration formula, x raised to the power n into dx is equals to x raised to the power n plus 1 divided by n plus 1. So what is x power here? 1. So that's equals to x raised to the power 2 divided by 2. So x raised to the power 2 divided by 2 and 0 to L, and that's equals to, so this m will cancel out and this will comes out to be 1 by L into L square by 2. So put the upper limit x equals to L here minus lower limit, that is x equals to 0. So 0 square upon 2, and this comes out to be 1 by L into L square by 2. Okay, so this will comes out to be, so this L1 1L will cancel out and this comes out to be L by 2. So hence you have calculated this x, the center of mass, x is equals to L by 2. So what are the coordinates? So there is no y coordinate, right? So you can simply write the 0 0, so center of mass 0, sorry, L by 2 0, right? Center of mass, if you write as coordinates xy, so that is L by 2 0. So this is, at the end you have to write the coordinates of the center of mass. So I hope this is clear to you.
Yes, sir.
Yes, sir.
So now we will take a case of okay, if students, if you have not noted it down, then I am giving you a minute to note it down. Okay, just note it down. After noting it down,